All right, now that we pulled that ring off and we got a rough diameter, we're gonna go ahead and we're gonna rough this out 4 1/4 inches down and 3-inch diameter. The finished diameter is going to be like 2 7/16, and the depth is going to be like 4 3/8, somewhere in that ballpark area. And so what we're doing is we're just picking a diameter here just to get some material off of this thing and kind of have it roughed out to dimensions. Okay, so we need room to swing this cut here, and this is really the short end. The other end gets a little bit longer. It's probably close to about 10 inches on the length or so. So we're going to go ahead and back off our steady rest. Our tailstock is in and tight. And we turn this area all the way back to about right there. But we only want to take what we actually need. And that gives us about 6 inches of travel right there. So it gives a little bit of buffer in here for chips to pile up. We're gonna try to speed up this process, and we're gonna try to get some bulk off of here. We have the steady rest now to really help hold this and the rigidity, so we should be able to create a bigger chip than we've been creating on stretching this thing out. All right, let's get her rolling. Okay, first off, I'm gonna come in here and I'm gonna kind of touch this area right here. We snuck into here to cut this, and I want to kind of make this all one size on the diameter here. And then after that, then we're gonna really start coming in. So I'm just gonna basically be just touching off here, coming back here, and taking one cut there. Okay, that one cut was like twice the depth we've been taking the long cuts on there. We were taking those at about 25 thousandths per side, and this one here was 50 thousandths per side. And it was just coming out here and skipping. So from here, we can take it on down. First off, what we're going to do is we're going to come in here and we're going to give a Sharpie line so we accidentally don't go past wherever it is we need to go. And we're calling that 4 inches. And we're going to rough it out, which that 4 inch is right there. That really comes in handy. All right, now we're going to go ahead and we're going to take this end down to 3 inch. And right now we're at 4 inches 3. 4 inches 300. All right, and I kind of that was feeding pretty good. I think we're going to continue that. We're going 50 at a side, and we're still feeding. We're right around 25 thousandths per revolution in here. Pretty coarse. You can hear it. It's almost like a chalkboard scratch. about 10 more cuts here. We're going 50 aside. Actually, we're going to have 5 more cuts. Right there is white, gold, purple, blue. That's a pretty good duration of color change there for optimum removal on this positive insert right here. Couple cuts here. I've been holding a little bit shy of the shoulder just to make sure I got plenty of material. And we're going to check that. I think it's one more cut. Alright. No, I was wrong. 2 more cuts. It's 3/200. Excuse me. Okay, let's get rid of some of this debris here. And looks like it kind of laid in there, all uniform. That's a pretty good wad. Alright, we're just going to come in here real quick and we're going to rough this radius right here, and then we're just going to kiss those two off with a D&MP insert there. In fact, I'm going to take the feed out, so we're just coming in by hand, and then that's it. All those guts up there. Alright, now there's nothing sharp that cut us or anything else there, and now we're going to go ahead and lift this up, rotate this around. We're going to chuck on this diameter, and then we're going to turn an area in for the steady rest or ride so that we have the length for our next reduced diameter for the other side of the drive and bearing side. Turn diameter into chuck here, and we're in the steady rest over here. We measured in, we're going to be about 8.5, so we kind of set up our tool bit to where we're at the end where we want to start, how we want to be cutting in here, and right about there. So what we did is we slid the steady rest in here, and we want to leave a little bit, you know, a couple fingers. You always want to leave room for at least chips. Chips, when they compress, they can get stacked up, and you can actually end up being pushing your and causing strain on carriage and all kinds of things there. So you just want to make sure you have a little bit of clearance. So I'm going to go ahead and I'm going to mark at least two, the front and the back, give or take, you know, probably give a 1/4 inch or so, a little bit extra or whatever, so I kind of know where I'm going to want this steady rest. Now I can go ahead and I can slide this back out of the way. Now what we're going to do is we're going to fire it off, and we're going to come in here and we're going to take a real light skim over that surface so we know that's running concentric with that center and the three jaw grip on that end there. All right, just for okay. All right, just anticipating that you would ask how much this is running out already. You're gonna have to take my word for it, but it's running out about 7 thousandths. So, and we'll go ahead and we just go ahead and start our feed and then engage it till we're smooth round cut. Take the very top of that off of there. Okay, we were able to sneak in there and we actually got a nice smooth surface in there. And now we can go ahead and we can bring this in. We're going to blow this off, make sure we got clean. Alright, we're ready to go for our first cut here. Let's jack our feed back up where it was. Down to 3 inches for that 8.5 inch depth.
Okay, we got both sides roughed out now. That's a big load. We're gonna have to make a run out to the trash.
Alright, we got a completely roughed out shaft now. We've got both of these diameters roughed out. They're within 1/4 inch or so, and length and radius and all of that kind of stuff that we, you know, those are important things. We left enough material on there. This diameter right here is really it's 1/4 inch, you know, or a little bit better than the actual diameter, but we are going to have a little bit larger diameter because the bore in that flange is considerably larger by about almost exactly 100 thousandths. It was a larger bore than that shaft. I have to think that that was not planned. All right, I'm going to go ahead and set this on the drill press there, and then we're going to go ahead and we're going to change out the chuck, and we're going to get the 4-jaw chuck in here. All right, let's get moving here. Alright, so we took this slug and we put it in on the flange here, up on this side here. It really doesn't need the blocks because it doesn't protrude through, but our other piece, we're going to measure it the same way. We're going to flip this over, put it in. This matches up with where it broke away from there, and that's sitting down in there as close as we can get it. And we went ahead and we measured. We got an in measurement here of 16.9375 or so, and we've got about 12 5/8 there. And that's we've jotted that down on our CAD, and now we're going to go ahead and swap this out, get the other side in there. We're going to get this in the lathe. All right, here we go, putting this side in here. We don't have any. You don't have to put this straight in because they didn't. You know, they didn't have a quality fit there, which I think is the main reason why this failed. Alright, so let's rotate it around until we find the magic spot, and by the looks of that peeling out, that, you know, the weld itself tells the map story also. All right. Now we can measure this side here, and this will be one straight measurement there and one measurement there. And of course this is a back side here, and I don't think it's all that critical, but we have to still pay attention as close as we can here. And it looks like 11 inches 30 thousandths. We're just going to go 180 over here just to see what we got here. Pretty close. It is pretty level there, so we're going to go 11 inches 30. That's 11 and a 32nd of an inch, basically. And this one right here is like 19 and 19 3/4. A little bit more over here. We got 850 there. This is a rough. This is not faced on the end here, so this could be angling somewhat. You know, I still get like 750 over there. I get like 800 there, and get like 810 there. We're gonna go ahead and call that 19,800. This side's open air. The other side's the one that has the bolt and the nut, and I think controls the thrust and everything else, and has that spacer ring on for the bearing. All right, we're good to go. We're gonna get this in so we can get that bore, the bore face and shoulders cleaned out. We actually we had it started somewhat in here. We didn't have it dialed in or anything, but we did kind of rough it out, so we knew to put it in here. So it, you don't want to pull any wool over your eyes there. All right, so we got this held this way, and this was why we kind of put it in, because I wanted to make sure that I was swinging my chuck before I had to decide whether to break loose my gap or not. We'll be able to run this job without breaking the gap loose. So we're going to come in here and we're going to face this side and bore this true with this register, this face. So we're going to dial these two items first. Then we're going to go ahead and come in here and clean and bore. And then we're going to turn it over and we'll clean the face on the other side. And then we're going to go ahead and chuck the shaft back up and create the fit to match this bore and get this mounted up and get this welded up together. Okay, we're giving it a little spin through here. We'll set that one at 0. Just benefit of doubt, plus or minus 1,000. And this one's on the low. So we're running about total of 50. So we're about 25 thousandths outside to side, and we are moving almost 100 thousandths, and that's the high, and we can see a gap behind there, so it definitely needs to be tapped back here. And actually it's bouncing. When you see it bouncing, you got to give it a little bit of tension there. All right, now let's see what we got. It's a lot better. Now we're dropping down here. We're running about 50, and we're still 50 or so here. Just going to bring the peripheral in, get it pretty close. Okay, that's about 3/1000 run out on the peripheral, and we're about 50 here on the in and out. Let's just see, there's the high. Alright, we're going to go ahead and we're going to get us a little tap here. One of my favorite tools. Okay, we're going to bring a little cinch here. We're about 10 here and about 10 there. Okay, I've got to manipulate it around where I'm happy with it, and I'm going to call it good. Now this dial right here on the peripheral is probably, it's probably a full thousandth, maybe a little bit less, maybe 8/10 that it's moving around. I mean, each revolution is just a little bit different. One revolution might look like 1,000, the other one might look like, you know, a little bit less than 8,000 or 8/10. Now this one up here, you got to go to jaw. You know, sometimes when you don't get a true reading, pinpoint your jaws. Okay, so we got 0 on that jaw. We've got -3 on that jaw. We've got 0 on that jaw, and we got like -2.5 on that jaw. So from jaw to jaw, both directions, we're within 1/2 thousandths. We're right on the money one way and within 1/2 thousandths the other way. And I'm calling that square. All right. So that is our 0. Well, we're switching our insert back over to our negative. Alright, I drug out a few inserts here just to give you guys that were inquiring about negatives and positive tooling as far as inserts going. This is a C&M and this is a D&M. And the last letter, either G or P, it tells it it's negative or it's a positive tool bit. Okay, now let's just take these two right here, which are, I'm going to hold them up here. I think that you can see them better in my hand. Alright, the one at the lower of your screen is a positive tool bit, and if you look at it from the side, you can see that it slopes back, and you can see that the sides of that one are fairly square, meaning you look at it this way right here and it's square edged. Now the shape on the top and everything is irrelevant to whether it's a negative or a positive. It has a chip breaker and a certain design that's put into that, but it's still a negative tool bit. Now also this is a positive tool bit, and you can see the slope on the side. Now these happen to be only cutting on one side because of the amount of material it takes to create that slope, almost like a spoon or a scoop. Alright, now the CNMPs and CNMGs, this is a negative here, and even though it looks kind of just plain Jane, it's a negative. It's straight sided. It's not really scooping it in. Now here's the same kind here. This is a little, I mean, some of these are slightly used, but this is a negative, and it just happens to have a chip breaker design in it. This one here is a little different vintage. This is probably This is the way they were making that same one I just showed you a couple years ago. Sometimes you'll order the same thing and you'll get it from your supplier and they've already changed out it, you know, and then you go, why you changed it? It was working perfect. You know, this one right here, this is like the all-time favorite right here. And this is the CNMP. And I love them. This is a general purpose coating on here, so I can grab this and I can just about go hit every kind of material there is. And that's a Sandvik insert. Alright, so that's it. At least that's a close-up. And you can see that there's various, and it's not the design or the top side creation is the geometry that they all put in to make the chip do different things, whether it's going to break or it's just going to chip and flake, or you know, they have different things that they do to the bits, and I'm not the expert that's going to tell you what they all do. I know when they work and when they don't work. And the positive is less tool pressure, and this is the winner right here. This is the one that you'll see taking most of that material off once I have it smooth. But these take more punishment. The negative tooling will take the pounding, alright, but the positives won't. So there's a glimpse of the inserts by themselves there. They fit in the same, I mean, all of these will fit in the same holder, and then these all fit in the same holder. And we're even putting the same surface or the same contact there that we were using right back in the same spot. We're not choosing a new one. The reason why we're going back to the negative, we're going to be pounding on this weld here, and we're going to be removing that weld across there. And I'd rather, you know, the positive seems to be a little bit weaker in that aspect. So, all right, let's go ahead and pick this up a speed here. That'll be fine. Alright, we're shooting, this is basically about 265 RPMs here. Going about 50 thousandths in. And we're running the base cut like about 8 thousandths per revolution. Seems to be cutting pretty free. I think this was wire fed, and it probably was some kind of 70 series wire. At the lab, because this face right here is running so far out. I know it's in the air, but it kind of shows you how much they just slap these things together and turn them as a whole unit. And both sides of this thing are really running out, and that's why it wouldn't set in against the jaws real nice there either. Okay, you can see this inside over here, and you can see this outside over here, and they both run about the same. Okay, because that bore was that far open, they just slapped it on there and then did a weld job. Now we're dialed into that face and that surface right there, and that's what we need to machine that bore to, and that's what we're going to go ahead and do. This surface right here and that surface right there, they really should be, you know, that causes an oscillation in the thing. Not so much of a out of balance, because it's not changing from side to side as far as the width, so it's not going wider, thinner, wider, thinner. Just wanted to point that out. You know, I don't know where these machines are made at, but you know, that's sloppily made too.